Are we live?
Yeah. So thanks for joining, everyone. Um, Today, Cyril will be talking to us about serverless and ML. I'll leave it to himself to to introduce himself. Um, Cyril, you must just tell us if you want to take questions during the presentation or at the end. We will have a short survey at the end that you can just fill in and then stand a chance to win a $50 AWS credit. So just a very short survey. Uh, and I think that's kind of it. We are recording this. It will be uploaded to our YouTube channel. We have a Twitter, a YouTube channel. We don't have a LinkedIn, but do follow us. There's other AWS meetups as well in Cape Town and in Joburg. So you can join them as well if you want to. And we'll try to get back to in person again soon. But for now, I'm going to hand it over to Cyril to talk to us about 3 ways to serverless machine learning. Thank you, Cyril.
Okay, thanks. Okay, can you see my screen?
We can.
Okay, good. Yeah, so thanks, Ryan. Thanks, everyone. Thanks for this opportunity. So I am Cyril Bandolo, an AWS machine learning hero. So kind of 3 years ago, I was interested in everything else except AWS. Then my friend introduced me, said, come attend our meetup, local meetup here in Cameroon. I'm based in Cameroon. Then I attended and I was convinced. And from then I started my YouTube channel, created my Twitter handle, started pushing content. And a year later, I was a hero. And a month later, I got a remote job for an AWS consulting partner called Serverless Guru. So I'm a developer at Serverless Guru just a month after becoming a hero in 2022 June. So like July, Serverless Guru. And for those of you also who have heard about AAI, that's the AWS Authorized Instructor Program. So I'm just 1 day old. I got in yesterday. So yeah, so I have really been my passion for teaching has made in such a way that I have tried to come close to my audience as possible. So that's what pushed me to the AAI. So as you can see, I come from a machine learning or data science background. So I have been in the analytics space for more than a decade before moving to the cloud. So I understand what the machine learning engineers are thinking or the data scientists are thinking. Then working for the AWS consulting company, I also understand what the serverless developers are thinking because the company is called Serverless Guru and it's mostly serverless projects that we do. So that's why I started thinking. And then I said, what is the knowledge gaps between these two fields? And that is why I came up with this theme of 3 ways to serverless machine learning. So let's go in and see what we have in store here. So for our agenda, we will talk a bit about serverless. So I know there are some, I could call them from my angle, traditional developers in the house who are maybe starting from web development and things like that. So we'll talk a bit about serverless as a standalone, then a bit of machine learning, because I'm like, we are like talking about best of both worlds in reality. So it's like the best of both worlds. So I'm like serverless on one hand, machine learning. Then now what now is serverless machine learning when we bring machine learning serverlessly, or we add machine learning to serverless development, to serverless workloads. And then I'll also talk about the 3 ways you can do that on AWS. I'm an AWS hero. That's what I know how to do on AWS. And also at the end, stay tuned. My advice for you. So I think we'll just do the question and answers at the end, as you can see here. So I'll just go ahead with the presentation, and then at the end now, if you have any questions and answers, yeah, if you have any questions, we can also look at that. So let's move on then. So generally, what is serverless? So the key thing about serverless, for those of you who maybe have started your journey in AWS, I'm sure you must have seen that EC2, you must have started maybe with EC2, with spinning up an EC2 instance. So you do a lot of configuration with the VPC, with all those other subnets, things like that. So you have to do lots of configuration and manage the servers, provisioning. But with serverless, as you can see, most of it is done. You would do in with your infrastructure. AWS would do little, you will do more, as you can see here: platform management, server-side encryption, network, operating system configuration. All this you have to do. But with serverless, as I was saying, it's more of what you have to do is pushed to the cloud. So the cloud handles most of the things that you had to do, as you can see in orange here, which means you're only left with your code, your data, and then if you want to do some client-side encryption, yes, you're left with those. So which means that there are really not no, it's not like there are no servers, but you are not the one managing the servers. The cloud provider is managing the servers for you. While now, the key thing in serverless is Lambda. That's the heart of serverless. So in 2014, Lambda was created by AWS, and that is where the serverless movement started until now. We get it. Most companies, they are like, okay, I want to go serverless because it's fully managed service by AWS. You don't need to bother about provisioning and managing capacity. So for those of you who have used maybe an EC2, you have spun an EC2 instance before, or you have created a Lambda function, you bear with me. There is no reason to bother about any VPC or any gateway or any port open or close. It's just about writing your Lambda function and writing your Lambda function. So Lambda is at the heart of serverless. And because Lambda is event driven, so it's good for applications that are event driven. And it's also helpful because companies like startup companies that want to have something like a pay as you go, you don't need to buy infrastructure, buy lots of servers, invest in heavy hardware. All you need to do is start. Maybe you just have a business idea. Today, we can start something. If it doesn't work, we stop. So Lambda is really at the heart of making it interesting. That's why serverless is very interesting because of that pay-as-you-go aspect. And also, Lambda integrates very well with other services. You would see Lambda integrating with DynamoDB, with step functions, with Event Bridge, with almost every service on AWS. So it makes it also so attractive. And that's why you have been hearing that serverless movement. And as I said, like my company, I work with Serverless Guru. Our workloads are mostly serverless applications we are building. So it's always interview for serverless developers, serverless developers, serverless developers. Now, it also supports many languages. Lambda supports many languages, as you must have seen. So now let's look at the mindset of a serverless developer. When I came to Serverless Guru, I noticed that most of the serverless developers come from a web development background. So they maybe started with HTML, CSS, JavaScript, and then it's more of the web development side. Then you would always hear most of the developers that are on serverless will be comfortable with Node.js because JavaScript is what came from the web development part of them. So it's mostly they are more comfortable with JavaScript, now more TypeScript, and even infrastructure as code because they do a lot of software engineering. Because I'll be comparing it now to the mindset of the machine learning engineers subsequently. So services like AWS Lambda, DynamoDB, API Gateway, AppSync. These are services that you would see a typical developer in a serverless mindset would be more comfortable with. And that's what you expect from someone who says that person is a serverless developer. But now, the problem is the serverless developers themselves, everybody, and even customers are seeing how the big tech is bringing in innovation with machine learning. Let's say I had an e-commerce app in those days. It would have been okay if I don't have some recommendation system in that e-commerce app. But nowadays, the bar is so high. At least when I want to create an e-commerce app, something should be there for me to recommend to people. So it makes it in such a way that the developers want to get to machine learning, but what is the fear? There's calculus in this thing, there's maths in this thing, there is statistics in this thing. So it causes that resistance to be able to bring machine learning to workloads because the serverless developers are aware that this thing is going to make me more innovative, more competitive because the customer's minimum expectation is higher now. There's also that, okay, I'm limited to my knowledge of the machine learning algorithms. I don't know what maybe k-nearest neighbors would do. I don't know what this algorithm would do for me. I don't know what XGBoost would do. I don't know what GenAI or whatever algorithm. I'm just like, I don't understand how it would help me out. So there is that thing that brings the servers developers back to their comfort zone. And also, like we've seen, most of the time, is the Python for data science. Yes, they could be Python for scripting, but that Python for data science, which goes towards not towards the Django, the Flash side, but mostly more towards the side of the scikit-learn, side of the pandas and things like that, and even the machine learning packages. So it's not there, and it stops developers from have to go start from zero to get to that level. So now let us look now at the machine learning engineer side. Then we will be able to see how the two can collaborate with serverless machine learning, and that's where I would land. So let's go on now. So on the machine learning side, where I traditionally came from, normally as a software developer, you get data, you program the rules. It's more of if, while, if else, if do this, if do this, you feed it to the machine. If this happens, give me this result. So that's the traditional way of programming before machine learning. What does machine learning bring on the table? Machine learning changes things, switches things. It says, here's a picture of a cat, here's a picture of a dog, here's a picture of a cat, here's a picture of a dog. Okay, now here are pictures. So cats and dogs. So look at that and find a rule. What I need is that rule so that tomorrow, if I give you any picture, you should be able to know, okay, the cat has maybe longer whiskers or ears or whatever. So it's more of like, I've given you all the answers, I've given you all the data. Give me a rule that I could generalize tomorrow to unseen data. So it's different from the traditional programming paradigm. So that is where things start changing gradually, right? Now, again, we need to address an elephant in the room when we talk about machine learning, because I get this almost all the time. There is the broad AI, which is anything we are trying to let a machine do. It might be just opening and closing a door, opening and closing a door every 2 seconds. That's an artificial hand opening and closing. It's still a machine doing it, but it doesn't necessarily need the machine to use past data like we saw earlier with past patterns, past data and past answers to come up with patterns. It's just something that every 5 minutes do this, but not a human doing it. So that is the part where it's the non-machine learning. The machine learning side is all about using data to be able to come up with patterns that you can use to, sorry, I didn't turn off my call. Let me just turn it down. Sorry. So machine learning is about using data to get your information. And you can have deep learning, which is now using neural networks in as a sub branch of machine learning, or other machine learning models which don't necessarily use neural networks. XGBoost, there are so many things spread. You have some time your data is stock data. It not stock data doesn't need Gen AI. So then there is Gen AI, which is still the subset of deep learning, which is more of now trying to create an original version of, let's say, I try to imitate this painting. Try to give me something that convinces me, that looks original, that looks unique. Try to look at what I could believe would be unique. So it has its own use case, but then all of that is still under machine learning, because LLMs will talk mostly of text, summarization of text, things like being able to ask questions, get answers, chat. But then there is also video. There are self-driving cars. There are other parts also that we are also needing to incorporate. So generally, all that fall under machine learning. So we need to be sure that we are talking about machine learning, and it entails everything, even what is hot right now, which is Gen AI. So what is at the heart of machine learning on AWS? On AWS, it's SageMaker. SageMaker is a Swiss knife. If some of you have used SageMaker before, SageMaker can do so many things, and that came in just in 2017. And it is a managed service, also AWS. So with SageMaker, you can be able to create your models. You can be able to train your data on models, built in inbuilt models, And you can also be able to deploy your models to production with the SageMaker endpoints. So SageMaker is really a Swiss knife. If anybody has used it before, it has pre-trained models. Some of them are Jumpstart. Some of them you can take them from your Gen AI models that are there for you already. You pick them. They have already trained them for you. You just use them with your data. Or you can also use built-in models like linear learner, random cut forest, things like that. They are built in. You select what you want. And also you can also use, they are managed, you can use managed instances to run your own models. So another thing is that it integrates also with other AWS services. That's why when you're in the cloud, you'll be working with your SageMaker as part of a whole pipeline when you're doing like MLOps with your SageMaker pipeline. So SageMaker is a Swiss knife, and it's also managed service. So now, where does the machine learning developer, where is the machine learning developer's comfort zone? The comfort zone is that, okay, I'm comfortable with analytics. For me, for example, I came from an analytics background, started with Excel, learned R, then later on went to Python when packages like PyTorch and TensorFlow and all those things. So it was an evolution. So I'll be more comfortable with Python and being able to do analytics at the same time, because like I said, things like your visualization packages like Matplotlib or Seaborn, those are packages that data scientists love to use to transmit messages, because at times you mix with data analysts, data scientists sometimes, so give me this chart, give me this, do it on Power BI. So it's really mixed in that. That's why things like Python, TensorFlow, PyTorch, we are comfortable with. SageMaker on AWS, we are comfortable with. But what we are envying, what I was envying some years back, or what I used to see, and I could not, I mean, I was trying to, was like, not even, was like, I was avoiding HTML, because the mindset at times is, okay, it's not like predicting anything. It's like, I'm just writing this bold, this padding, this size, this CS, I mean, making this styling. I have to write it again. I have to write the point, this 1.6 times color is this. So I didn't like it. I was doing actively running away from it. So which means that many of the time I would prefer to go train a model, do a Kaggle competition, get accuracy, make it to predict more, and I'm happy. 90% accuracy, 95% accuracy. So we spent less time on learning how to do CI/CD, good software engineering practices, clean code, things like that. We ignore it because as soon as I fall on a data set, I'm trying to make it accurate, 99% accuracy, false positives, so area under the curve is high, I'm happy. So we miss out on that aspect of, give me an end-to-end product that I can give you an API that users can send a request, get all what they want, and then get back a response, and everybody's happy. So that is where now we are now talking about serverless machine learning. So when it's just serverless, like we saw earlier, we are talking about, okay, I'm handling the code and the client side. But with serverless machine learning now, the ML code now comes into the picture. So in that serverless architecture, that serverless computing, that serverless framework, that serverless way of thinking, I want to fit in my ML code so that I can be able to profit from your serverless framework. SAM, CDK, I can be able to profit from the fact that you do so many things automatically. You're able to build your infrastructure, your cloud formation, all of that. I just bring my machine learning and slot it in there, and then I'm able to benefit from all that the software engineers have been enjoying all this while. So serverless machine learning brings the machine learning engineer that serverless mindset, that serverless ecosystem, that serverless exposure, what the magic that things like serverless framework are doing to be able to bring things to life. And then now the serverless developer now is able to integrate machine learning into a pipeline that the serverless developer is already used to, already comfortable with. So it's just bringing now the ML code in the scene, and that's what serverless machine learning is. So why would some developers who are here, some of you developers, love it?
You love it now because I'm talking now from the best of on the side of, okay, a serverless developer or a web developer or a software engineer. Now I can do more innovative and modern apps because, as I said, I have my e-commerce app. I am able to get items, order items, whatever. But at the end of the day, somebody wants to be recommended the next product to buy. Somebody wants to say frequently bought. These are the product you bought this, and you also people bought this, also bought this, things like that. So at minimum, you'll be happy because you'll be able now to have more innovation in and a more modern app based on what customers just naturally expect. So you don't need to get through all that maths if you are going through serverless machine learning, as I'll show you some of the 3 ways. You would not need all that maths because if you want to go through this machine learning route, okay, you go and start from, okay, let me understand statistics, let me do some calculus, let me do some gradient descent, let me understand so many things that are backward propagation, forward propagation, lots of things I have to understand how they work out. But with serverless machine learning, we are taking a shortcut for the developers. So that's good news, right? Now, we are also leveraging the cloud service integration. I'm sure there's a typo there. It's supposed to be cloud service integrations. So we are leveraging the cloud service because pandemic happened. All of us saw so many things. Now almost everything is in the cloud. We just say, okay, we are already in the cloud with S3, with our Glue, with our Redshift, with our RDS or Aurora. Let's just link things together and continue in that flow. So it also helps because the serverless is successful with the cloud as your shoulder you are leaning on. Now, it also helps with developer velocity and efficiency. Yeah. So that means that now developers are able to, you can go fast. You don't need to go through those calculus stuff for a year or so to learn all of that. You're able to slot in components that would already make your application to be what you want it to be. So now on the ML side, my former side before I joined the serverless guru, I'm happy because I don't need to provision servers. I don't need to spin up an EC2. I just need to dance with the serverless wave and I'll just be fine. Just go with the flow. Now I can also have more application integration because I've been on model accuracy, things like that, hyperparameter tuning, things like that. But now I have a big picture of where are my customers coming from. I need to make sure there's some cognito to filter them out. I need to make sure that at the end I have my event bridge, which is getting listening. And so I am now I think more somebody who wants to integrate a solution and provide to a customer an endpoint that solves a problem. Also, cost optimization now. Again, I would have spun up an EC2, and whether traffic up or down, I'm going to pay per hour. But now, it's a true story. I was playing with ML my first few days when I just started. I forgot to turn off. I forgot to turn off an endpoint. So I got credit card shock. So it has all happened. If it has happened to you, then maybe you haven't really started learning, but that's fine. So now you also have more team collaboration as well because you are working now with other team members who are bringing in their own bit of the front end, other parts, security, other parts of the development, because you are now thinking of a whole application so that you can be able to take your work even from one environment to another with your cloud formation, developer velocity still, being able to do more because you now are able to work with the serverless architecture and the frameworks, SLS deploy or whatever, very quickly. And at the same time, your infrastructure is in the 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 cloud formation template. So now the first way and the easiest way to go about serverless machine learning is to look at those AI services. You have AI services like recognition, personalize. I've seen many production clients that use personalize on their application and they are doing very fine to be able to give them recommendations. So with your application that is running, you look at those AI services. That's the easiest because you don't need, it's just an API. You don't need to know, you haven't experience with machine learning. most of those APIs, they continuously learn from your data. So they'll be improving the outcome for you with time. So they are your support. Give them your data, they learn, then they give you better predictions. They also integrate easily with your app. It's just an API. You call an API, it comes to your rescue. No need for calculus, no need for gradient descent, no need for backward forward propagation or transformers or whatever, or attention and things like that, or stable diffusion. You don't need all of that. So this is the easiest. And if some of you have looked at some of these services before, you know that we have services like recognition for face. You can use it for face recognition in your application. Maybe your application needs a certain part where we have to authenticate users with a facial scan. You just call recognition. You can take something like transcribe in a situation where you have a speech that you want to put it to text and then do whatever you want to do with it. Transcribe is there for you. Somebody speaks, it takes it audio and then it converts it to text. And then if you want to put it through your LLM model, now it's a text, your LLM model is going to give you whatever result they want. That's fine, but transcribe is there for you. You have the other popular one that people use is comprehend. So at times you want to get sentiment analysis, you run a campaign online, you want to know, is this campaign, are people happy about this new product or they are more negative? So you might be gauging the sentiment scores and you might see that, okay, the recent product we launched, we saw that the general sentiment of our customer base went negative. So it gives you information with an easy integration. Also, you have at the second level now, when you want to be able to customize or use your built-in data, for example, your built-in model. So SageMaker is there for you, and that should have they should be December 2021. SageMaker launched SageMaker serverless inference. So before 2021, you would spin up, you would create your SageMaker endpoint, and be sure that don't forget to turn it off, which happened to me. But from reInvent December 2021, there is this new, relatively new SageMaker serverless inference, which does just what it says it does. Lambda is kind of integrated into the endpoint, so you don't manage any servers. It also integrates easily with your MLOps pipeline when you want to build a machine learning operations pipeline, which is from data, because machine learning operations is a combination of data engineering, bringing in the data, quality data, garbage in, garbage out for machine learning. Then you have the DevOps for machine learning, because machine learning is kind of a bit different from traditional programming. So MLOps will understand what the data scientist is trying to do with the machine learning code. So you have the DevOps side and then you have the machine learning side. So MLOps is a mixture of DevOps, data engineering, and machine learning, understanding how to bring that to the operations team to consume. You can also host your models in the model registry. So this is very good for fluctuating traffic. I've used this SageMaker serverless inference. It was a lifesaver because it scales down to 0. I don't care about the app. I mean, I've put it on. If there's a user, it's going to go up. If there's no user, it goes down. I'm not watching every time. No, it's more than an hour. It's more than 2 days, more than a month. I need to shut down. As soon as you've created your endpoint, you've connected it to your clients, you don't worry. It's serverless, as it says. It's serverless inference and pay per use, just like serverless. Also, you can also have some provision concurrency if you want to avoid the cold starts issue that we know comes with serverless. So this means that now we maybe are not satisfied with the personalized in that our application, because maybe we want to get some specific model like random cut forest or even XGBoost, which is SageMaker has a container. XGBoost, remember, is one of the top models that has won Kaggle competitions. XGBoost. So SageMaker also has the container image for it. So it might simply mean that I want to build my own XGBoost model. Then I use my SageMaker serverless inference to be able to serve that model serverlessly. That's fine. Maybe I personalize. I want to use what they call ensemble, combine 3 models or 4. It's like voting. If 3 out of 4 models say that this is a cat, then it's a cat. I will do that with my SageMaker serverless, with my SageMaker, and then serverlessly serve the endpoints when they are inferencing. So the third is using Lambda container image. So I think also in December 2021, the limit was moved from 250 megabyte to 10 gigabyte. So your container can be as big as 10 gigabyte. So you're deploying Lambda functions as a container image with all the dependencies, with everything is wrapped up in a container image, and you push it to ECR. So what is the use case now? I want to create our own model. Again, like that, I think the best example is even that example of the ensemble. We want to create our own model. We want to, maybe we have a researcher in our company who has created a new model that has never been seen before, never exists, or is based on our reality. So it's not, there's no container for it on SageMaker. We created it ourselves. So now we want to be able to use that, our new model, to push with a container to serve our customers. So what is inside is our own creation. So up to 10 gigabyte of memory, and it supports the runtimes that Lambda supports: Python, Node.js, Java, .NET, all the runtimes that Lambda supports. So you are actually packaging all your libraries and your model weights. So you created your model, you're satisfied with it locally, or so you package it, and everything is a snapshot of what you've done, and it's going to repeat itself in the cloud. Things like pandas, scikit-learn, pytorch, they are relatively light. They are very good use cases for this kind of situation. So if you have a pytorch model, you can easily use your Lambda container image, build a model with all its libraries, all the weights, push, and it does just exactly what you want it to do. So, and also, it is easier to do model versioning, because with your container tags that you'll be having, since you'll be using Docker and ECR, most likely, each version of your container image that you're pushing would be able to tell you that this model version was what was the most accurate or what was performant. At the end of the day, we can always go back to an older version that gave us the best results. So now I'll go to my advice so that we can maybe go to questions later. So my advice is, try to think microservice, because with microservices, everybody is able to do their own bit. The front end would be able to do what they best do with the React, or whatever they best do with, they will be okay with that. The ML engineers would use the best techniques they want to do to make sure the model is as accurate as they want it to be, with the hyperparameters that they want to be. But at the end of the day, the APIs will communicate with each other and can scale differently, or can be able to perform differently, because they are all small blocks that are kind of independent but work together. So that is one of the biggest things, that when we start thinking like this, we should be able to know that you might need things like, if you're using serverless framework like serverless compose, to be able to do a multi-stack. There is the front end stack, there is the back end stack, and maybe the front end stack depends on the back end stack. So when the back end runs, the front end now runs, and everything comes together. So while you're working on your back end, doing your own thing, the front end is working parallelly. Everybody is working, and then and then at the end, we come together, we push. That's just an example, but we need to start thinking, both the machine learning engineers and developers, that we are now on a serverless machine learning mindset. Microservice is our first thing that we need to think. And of course, the second thing from Werner, go build. So we need to build. The key thing is, we need to build. So as much as we can, to be able to learn from the availability of these services that we have available, because there are so many services on AWS. Nobody masters, I don't know even what percentage of those services. So I'm okay. Any questions? I'm ready for that now. Thanks so much.
Thanks, Cyril. That was a nice presentation. I think let's leave it to the floor. Yeah. Ratu, you can go.
Yeah. First of all, thanks, Cyril. That was a very good presentation. Just got a question about deploying the Lambda functions as containers, right? Um,
Yeah.
I imagine, and correct me if I'm wrong, if we do that, we
Yeah.
would then have to like manage the ECSs, right? And stuff like auto scaling and stuff. Wouldn't we then be losing the benefits of Lambda functions and like running serverlessly?
That's a great question. But in reality, it's different. ECS doesn't come into play if you've done it. So I'll just add, maybe permit me, I'll plug in something here, Rihan, permit me. I'm currently creating a course, right? Called serverless machine learning with hands-on projects. Each of these have separate projects, right? So on one of these projects, which we are talking about, we are actually using just ECR as our repository just to store the image that we've pushed to our cloud. You have nothing to do with ECS, nothing to do with tasks, nothing to do with services. You just simply call the endpoint from ECR and the Lambda container image does the magic for you. You don't need any autos, no configuration. As soon as you put it in ACR, then you're able to call the model, the model that you've registered in ACR. That's the whole aspect. That's the whole beauty of it. You don't need any auto scaling. Yes, probably maybe we should get in touch. The course will be out soon in a couple of months, I guess. Maybe we'll get in touch to do more hands-on. It's really interesting. When I saw it, I said, wow, I need to talk about this, right? Thanks so much for that question. Yeah.
Like just to add to that as well. So like the Lambda function containers scale exactly the same as a normal Lambda function. So it's quick. There's nothing. It's not like ECS, like Cyril mentioned, because there you have to have your scaling policies and step scaling, and you have to turn a lot of knobs. But with the Lambda containers, it scales like a normal Lambda.
Yeah. Thanks for
Who else
that
has a
question.
question?
Yeah.
You can raise your hand while I ask Cyril a question. Like Cyril, like you mentioned, CDK and SLS. Like, what do you prefer, and what are you working with at the moment?
Yeah.
What do you think is
At the
better for?
moment, what I'm using for the course is serverless framework. Yes. I know that many developers want to stay with CDK because of the programming languages that they are comfortable with, so that you can use it to build. Yes, but I mean, for me, I say whatever you're comfortable with. The space is it is so much. I mean, our worry is not what you are using, right? There are so many there are so many big things I want you to worry about, but I would say I use serverless framework and I'm happy with it. Yeah.
We have another question there. Do you see it? It says, have you used AutoML, and what was the use case?
The truth is, I haven't used AutoML. I'll tell you the truth. I'm really old school. You know, I'm really old school. I'm old school. So we are these people who like, okay, yes, I will see it coming, but there's that. Please don't take out the developer fun in me, because if you do, you've taken away everything from me. So I always get this question, right? And I need to really start using some of this so that I can answer. But I mean, I'm very honest. I'm this old school guy who was like, I love the fun first of all. So I want to be writing code. But then they are, yes, they would normally have their use cases, but most of the time is between sacrifice between configuration and AI services. You're not doing much. It's just between the trade-offs, how much control you have. So to start with or to do something simple, there are many use cases that AutoML would just do the work. So it can be okay. But I've not used them myself. Sorry. I'm old school.
Okay.
Okay, so do you have any recommendations for large data sets that are available publicly? Yes, I know Kaggle has some data sets that if you want to play with machine learning, and also the interesting thing about Kaggle is that there's lots of sharing there. There are notebooks, there are like, I'll just say there are answers, or people have shared what they have been doing with the data. So it's a very good place to go, look at the data set, then look at some examples of people who have done things with the same data that it's really open, it's really free out. Say just check out Kaggle. There'll be lots of interesting things and lots of interesting solutions for you, Kim. So yeah, okay. Pius said kaggle.com. Thanks, Pius for sharing. I hope I'm pronouncing the names correctly. If I don't, please forgive me. Yeah, I just like calling names. Yeah. Okay.
Open data is one
Yeah.
I heard about.
Data. Yes, there's so many data.gov. Even you have these APIs now that are also you can also go get APIs and get data from there. So there are so many, but Kaggle, I love it again because of the fact that solutions are there. If you're interested in data science, exploratory data analysis, all those things are there. Yeah. So, any more
Okay.
questions?
Drop them in the chat if you have them. Otherwise, I have one last question. So you mentioned that serverless inference of SageMaker scales down to 0. But is there like a cold start into it to warm up, or is there a minimum charge, like a 1 hour minimum charge, or is it like truly serverless?
Yeah, it's truly serverless. Is truly serverless on its own. Maybe we could talk about the serverless domain because you have an EFS for your domain when you create it because you're storing some things. But on its own, it has that option of you doing provision concurrency to warm it up. But otherwise, it actually scales to 0 as a model. So I have applications that I've just left there, but when I'm using the traditional real-time endpoint, I have to remember to turn them off, to delete them.
So
Yes.
like, what's the cold start time for it to warm up? Is it 10 seconds or something? I guess that's why there's always
Yeah.
that.
Yeah. I think I don't have a fixed figure.
Okay.
Yeah.
That's fine.
Yes.
I was just wondering, like, if it's like this quick, like normal Lambda functions, or if it takes a while for it to start.
It's like normal Lambda functions.
Okay.
Yes, it's like normal Lambda function because as I said, the reality, the truth about it is instead of you building a Lambda function and putting in front of the model, AWS did it for you. I mean, I'm talking the engineering part of it. AWS just place a Lambda function in front of your model for you. That is what is called SageMaker serverless inference in reality. They did it for you. You could have done it yourself, but to save you the pain, they just put a Lambda in front of the endpoint for you. Each time you call it, you call the Lambda, and it does that for you. Yes, so
Okay.
it's actually a Lambda. Yes, but you
Thanks.
don't
That's
see
cool.
it. Yeah, you're welcome. Welcome.
I'm gonna share my screen now. Yeah. Let's see. Is it sharing my window or my old screen? No, it should be
Okay,
just
I'm seeing
sharing.
shop right.
Yeah.
Yes, click to spin.
Yeah, it's
Yeah.
so let's see. Let me refresh. I want to see you filled in the survey. I'm gonna throw the names in here, and we'll spin the wheel to see who wins the credits. We only have 2 names. Nobody filled in the survey. Like, not a lot of people. It's fine. But I do have enough credits in to give both of you a credit. So Okkert and Bias, I'll send you a email with a credit. Thanks for filling in the survey.
Cool, thank you.
Yeah, no, I'm excited.
Hello, Roger. It was up there in my previous message. If you do want to fold, I can't guarantee that I have enough credits, but it's there. Other
Okay,
than
but
that,
just to add, sorry, just to add, yeah, I think I have some credit, so I'll add more, yes, to the winners as well. I have some credit, yeah. So I'll give more for those who want to build. It's okay. I'll add more
okay.
credit. I have $50 credits too. Couple of them. Yeah.
Thanks
Thanks.
a lot.
Yeah.
I'm gonna
Welcome.
stop my screen share and fill in the survey if you still want to. The link is there. But Cyril, thank you very much for your time. It was nice to learn about how you approach serverless and ML. It was insightful. Thanks.
Thanks so much. Thanks so much for having me here. Thanks everyone, and
And thank you,
go
everyone.
build.
We'll do this again. Yeah, go bold. We'll do this again. I'll upload this video to the YouTube channel. Also follow us on Twitter and keep up to date on the meetup pages. I think the next one will also happen this month. Yeah, I think it might also be something serverless. I'm not sure.
Okay.
But
Okay.
to follow us, thank you, everyone. Have a nice night. Bye bye.
Bye-bye. Bye-bye. Thanks so much. Yeah.
Thank you.
Yeah.
Yeah.
Cheers.